In this video we're going to look at solving for the missing angle when we're given some parallel lines and a line cutting through those two parallel lines. So these two symbols here mean, these little arrows mean that this line here is parallel with this line, which simply means it's pointing in the same direction. And we have a line cutting through those two parallel lines. So in these particular problems, if we're given any one of the angles, it could be any one of these, it means we can solve for every other angle in the problem. So for example, if we're given this angle here and we call that A, maybe this is 100 degrees, we'll be able to solve for every other angle here in this shape. But how do we do that? Well, we use a set of rules, and we can also look at this problem with our eyes and see what matches up. So we just rub this out. We can see that because we have two parallel lines, we can basically look at this thing and say and see the matching pairs. So we can see that this angle here, with the line going there and the line going there, matches up with this angle here. Because these two lines are parallel, we know it's simply just copying this line and putting it here. So we know those two angles match up. The same with the other ones, this one here and this one here match up. Then we can look on the other side of this line cutting through the two parallel lines and see that this one here matches up with this one here, and this one here matches with this one here. There are other ways we can solve for these missing angles as well. We can use some rules. So if we have two lines, we have the point they cross here. The angle here is always the same as the angle here, and the angle here is always the same as the angle there. So opposite angles are equal. That is one rule we can use here. So for example, if we know the angle here, the opposite angle is here, which means those two angles are the same. And the same for this one here, the opposite angle is here, so we know those two angles or numbers are the same. Another one we can use is if we have a straight line, we know that going back onto itself is 180 degrees. So we can see here, if we're given maybe this one here, but we're not given this one here, but we know the angle going all the way onto itself, so the straight line, we know that is equal to 180 degrees, but we know this part of it, so we just need to subtract that part to get this part of it, the other section of that angle. So straight lines add up to 180 degrees. Another example, if we're given maybe this angle here, but we're not given this angle here. We know there's a straight line going there, so all the way around back to the line itself is 180. So to find this angle here, it's just 180 take away A equals the missing angle. So that's another factor we can use. In this video we're going to look at solving for the missing angles on these sets of parallel lines. So for the first one here, number one, we have two parallel lines that are going in the same direction, and we have one line cutting through those parallel lines. The arrow means they're parallel, which means those lines are pointing in the same direction. We're given this angle here, 70 degrees, and we're asked to find the angle theta here. Now we can see that if we have this parallel line here going in the same direction as this parallel line here, and we have a line cutting through those two parallel lines, this angle here is going to be exactly the same as this angle here, because this line is straight, which means those two angles have to be the same. So theta equals 70 degrees. Okay, for number 2, we have two parallel lines going in this direction, and we have a line cutting through those two parallel lines. We're given this angle here being 110 degrees, and we're asked to find the angle here, alpha. Now, we can do this in a number of different ways. We know that this is a straight line here. So if this is 110 degrees, going all the way around onto itself here, that's 180 degrees, the total, going from here all the way to here. So 180 take 110 is 70 degrees, so that one has to be 70. So we automatically know that this angle here will match this angle here, because that line is going in the same direction as that line. So this one here will be 70 degrees, and this angle here matches this one here, which is 110 degrees. We also know that this angle here is exactly the same as this angle here. When we have two lines intersecting like this, we know that this angle here is the same as this angle here, and this angle here is the same as this angle here. So opposite angles are equal. So in this case here, alpha equals 110 degrees. Okay, let's have a look at the final one, number 3. We have a parallel line going in this direction, and another one going in the same direction, and we have a line cutting through those two parallel lines. We're told that this angle here is 85 degrees, and we're asked to find the angle beta. So we know that because we have this straight line cutting through here, we have a line here that's parallel with the line there. So we know that this angle here is going to be the same as this angle here, exactly. And we know that all the way around from here to there, because that's a straight line, is 180 degrees. So beta equals 180 degrees, take away 85, which is equal to 95 degrees. So that is just a couple of different ways to solve these angles where we have parallel lines.